In this video, we're going to look at two special types of quadratics, and the first one is factorising perfect squares, which you'll remember from when you did your expanding. So a perfect square is when we're going to end up with our answer where the two brackets are the same. Okay, so we'll go through a question. So if I said to you, factorise x squared plus 10x plus 25. Okay, now you're not going to know that this is a perfect square until you actually factorize it. We're not going to say this is a perfect square. You've actually got to figure that out yourself. So what we're doing here is we need to factorize this, and we go through our normal situation where we look at our C value, our term that doesn't have a letter with it, 25 in this case, and we say, well, what are the factor pairs? And so obviously here we've got 1 and 25, 5 and 5. We've also got the negative variance of it, 1 and negative 25, negative 5, and negative 5. And so we're looking at those there, and which ones there out of all of these here add to plus 10x. And of course, it's fairly obviously, it's the 5 and the 5, because 5 times 5 is 25. That gets us this value here, and 5 plus 5 equals positive 10. So our answer in this case is going to be x plus 5, x plus 5. And we call that a perfect square because they're both the same. Now, if you leave your answer like that, technically you're correct. But for a higher grade often, especially at year 10, we want to simplify that a little bit much. And because these brackets are both the same, we've got x plus 5 here and x plus 5 here, we can simplify this a little bit further by simply going x plus 5 in brackets. And because there's two of them, we square it like that. Okay, because that's, those are two terms, and if you've got two terms that are the same, you can square it. It's a bit like saying, well, we've got 3 times 3, haven't we? They're the same terms. Another way of writing it, of course, is 3 squared. So that's factorising a perfect square. And I'll give you another example. Let's say we had, I'll just put a different colour here, factorise. Okay, let's say we'll go x squared, and we'll go minus this time, just to make it easy. We'll say x squared minus 12x plus 36. Okay, so for this one here, we go through the same process. We don't know this is a perfect square, so we're just going to check it out. So first of all, we've got to find the factor pairs at 36. And of course, we've got 1 and 36, and its negative versions, negative 1, negative 36. We've got 2 and 18, negative 2, negative 18. We've got 3 and 12, of course, negative 3, negative 12. Got 4 and 9. Probably should have chosen a different number here because we've got a lot of these, but minus 4, minus 9. 5s don't go in there, and of course we've got 6 and 6, and negative 6, and negative 6. So which ones out of all of those, when we add them together, get to negative 12? And obviously the answer is the negative 6, negative 6. So if we were to factorise this, we'd end up with x minus 6, all in brackets, x minus 6. And because they're both the same, we can simplify it further. X minus 6 all squared. And that would be your answer in this particular case. And on the next slide, we're going to go on to the other type of special case, which is factorising the difference between two squares. So in this question, we've got the factorising the difference of two squares. And these ones are pretty easy to spot because you'll end up with an x squared, and then it's always minus, and then some number. And one thing you'll notice about that number is it's always a perfect square of some sort. So it's, 1 squared, 2 squared, 3 squared, 4 squared. In this case here, 16, of course, is 4 squared. So when you get this here and you're asked to factorise it, it's quite easy. All you need to do is look at this last number and say, what are the factor pairs of 16 that are the same? So you just do the square root of 16. That's essentially what you're doing. You're doing the square root of this number here. So the square root of 16, of course, equals 4. So therefore, you simply go into brackets. You go x plus 4 x minus 4. And that's simply what you have to do. That is the difference of two squares. Basically, it's the same number, in this case 4, but one's got a positive, one's got a negative. Let's do another example here. If I said x squared minus 400 as an example, what you do here is you say to yourself, okay, I'll look at this last term here, this minus 400, and I'll just go, what's the square root of 400? And you'll do that on your calculator and you'd get 20. Not that you can use your calculator in this assessment, but you should know what 20 times 20 is. And so therefore you would have your brackets set out as x plus 20, x minus 20. Now you can have those two brackets around the other way, it doesn't matter. It still comes out the same. Okay, so that's how you do the factorising the difference of two squares, because you can see there that you don't have an x term in there, and all these numbers will always be squares for you. Just as an aside, what happens if you've got a fraction? So we'll just do one more question here. Let's say we've got a fraction. Just do it in a different colour. So let's say we've got x squared minus, and we'll go 49 over 100. Now, we'll always make these numbers nice and simple for you at year 10. So you're going to do the same thing again. Now, how do you find the square root of a fraction? So we're going to try and do this. What's the square root of 49 over 100? Well, that's the same as saying, okay, so I'll just say that's the same as saying the square root of 49 over the square root of 100. So therefore, that, of course, is 7 over 10, because the square root of 49 is 7, the square root of 100 is 10. So our answer here would be x minus 7/10, x plus, just put that in brackets, 7/10. So keep an eye out for those sort of questions. I sometimes like to throw questions like that into your test, and that's very much a harder sort of question.